Hello students, once again welcome you to GK's maths classes. Today we are going to do the last part of inverse trigonometric function. This is a part 6 of the video. Today we are going to solve more problems. Some of the questions are proving type, little lengthy and little difficult also. So let's go into the video. So as a routine, please subscribe to the channel and also click the bell icon for notifications. Okay, I will also put the link of all the 5 parts of this video in this, so that if you want to clarify the introduction, you can go to the part 1 of the video, and also if you want to go through the problems, you can always click into the other descriptions or other link in the description, so that you are able to understand the full chapter. I hope these videos are very useful to you. Let's go straight into the problems. Now these are all very nice sums. Already we did around 7 questions last class about reducing it to simplest form. But today, as a continuation, I have written sine inverse of 3x minus 4 into root of 1 minus x squared by 5. And in the previous video, I've also put a page where what substitution to make when. So you can always click the part 5 video to understand. If I keep writing, it will waste a lot of time. So here, if you notice very carefully, 3, 4, 5 are Pythagorean triplets. So that is something that you have to watch. Okay, 3, 4, 5 are Pythagorean triplets. Then what happens is, since you have root of 1 minus x square, I will put x as sine theta. If you want, you can put x as cos theta also. So here I will put x as sine theta because it is root of 1 minus x square. So this will become sine inverse of 3 sine theta minus 4 root of 1 minus x square. Root of 1 minus sine square theta will become root of cos square theta. So effectively this is cos theta divided by 4. Divided by 5. I hope this part is clear. So this is sine inverse of, I will make this as sine theta, and I will write 3 by 5. I am just splitting the term, dividing it, minus cos theta into 4 by 5. Sine theta into 3 by 5, for cos theta into 4 by 5. Now what I will do, I want to bring this in terms of sine. You know, it's already sine, here it is cos. So this should be written in terms of cos, and this should be written in terms of sine. So I will take 3 by 5 as some new variable cos A. So automatically 3, 4, 5 are Pythagorean triplet. So sine A will be what? It will be 4 by 5. If you want, I can draw the triangle for you. This is A. Sine A is 3 by 5. By Pythagoras theorem, this is 4. So, cos A, no? This is 3 by 5. So, sine A will be 4 by 5. So, now take all these things and substitute here. So, you get sine inverse of sine theta into, what is 3 by 5? It's cos A minus cos theta into, what is 4 by 5? It is sine A. So now you have this formula. What is the formula? Sine of A minus B is sine A cos B minus cos A sine B. I am using this formula. So you can see sine A cos B minus cos A sine B, which is sine inverse of sine A minus B. And I assume strongly they lie in the principal range. So what is sine inverse of sine theta minus A? It is theta minus A. Now what is theta? I have put x as sine theta. So theta will be sine inverse of x. And A, you can write it in terms of sine or in terms of cos, or you can write in terms of tan. So since sine and cos both are positive, it should be in the first quadrant. So it doesn't matter, I write in terms of what. Okay, so this will be sine inverse of 4 by 5. Since it is sine inverse, I prefer to write this also in terms of sine inverse. So this gets reduced to this. Okay, I hope this is clear. I mean, this 3, 4, 5 can also be, sometimes the exam they'll give you, I'll just change it. If you can try it as homework. You can write ax minus b into root of 1 minus x square. What should be the denominator? Pythagorean triplet. So it should be root of a square plus b square. So you can try this problem. You can put x as cos theta here. I prefer cos because you know cos a minus b will be cos a cos b minus sin A sin B. That will be cos of A plus B. I'm going to use this here. So I want these two should be to be in terms of cos, these two to be in terms of sine. So if I put x as cos theta, this will become sine, so it will work out. So the hint will be you put x as cos theta and follow the same procedure, you'll get the answer. Of course, here the formula will be different. Here it is sine inverse, here it is cos inverse. So write this in terms of cos. I hope it's clear. Let's go to this next question. Reduce to the simplest form sine of 2 tan inverse of root of 1 minus x by 1 plus x. As I mentioned to you in the last class, in the last video, which you can check in the description box, I have also told you what substitution to make when. Okay. So here the situation is I have both root 1 minus x as well as root of 1 plus x. In such situation, I have written very clearly that put x as cos theta. Put x as cos theta. Okay. So this will become sine of 2 tan inverse of root of 1 minus cos theta divided by 1 plus cos theta. So this becomes sine of 2 tan inverse of, what is the formula of 1 minus cos theta? It is 2 sine square theta by 2. 1 plus cos theta, it was 2 cos square theta by 2. I am using this formula. 1 minus cos 2a is 2 sine square a. And what is 1 plus cos 2a? It is 2 cos square a. So 2 gets cancelled. So what you are left with? Sine of 2 tan inverse of, actually it is tan square, root will make it tan. So what is tan inverse of tan theta by 2? Yes, it is theta by 2. They get cancelled. So you are left with what? It will be sine theta. But always the answer should be written in terms of x. So my substitution was x is cos theta. Am I right? So I'll draw a triangle. Cos theta is x by 1. By Pythagoras theorem, this is 1 minus x square. So you can write sine theta as root of 1 minus x square. Or you can even write this as 1 minus cos square theta. And since cos square theta is x, it is 1 minus x square. So these type of problems are very important, not just in inverse trigonometry, but it is also very important when you do problems in differentiation, where they will simply say differentiate this with respect to x. So you have to bring it to this form. You have to use inverse trigonometry, bring it to this form, then only differentiate. Is that clear? Okay, let's go to the next question. This is a proving sum. It is very, very important. Used to be very, very important type of question, but of late with the revised syllabus and all that, I don't know whether these things are even but it is possible to do. Okay, so we'll try to do these problems. It's not difficult. Okay, so let us assume it's there. If it's not there, it's not an issue. But suppose if they ask these questions, what will you do? So that is very important. They have not said very clearly that this is not there. Okay, that's another issue. So here what I will do, as you know, it is cos inverse of a by b. So I will take a by b as cos theta. If it was sine inverse, I would have taken sine theta. So this will become tan of pi by 4 plus cos inverse of a by b will be theta. So it will become effectively theta by 2. Plus this is tan of pi by 4 minus, this is again theta, so it will become theta by 2. Now what is tan a plus b formula? Tan a plus tan b by 1 minus tan a tan b. I am using tan a plus b formula. Tan a plus b is tan a plus tan b by 1 minus tan a tan b. Here my a is pi by 4, so tan pi by 4 is 1. I didn't write it. Okay. What is tan a minus b? Same thing. Numerator will be minus, denominator will be plus. It is tan a, tan pi by 4 is 1, minus tan theta by 2 by 1 plus tan a tan b. Tan a is pi by 4, so I am not writing it, tan theta by 2. So that is 1. Now you take the LCM. If you take the LCM, a plus b into a minus b will be 1 minus a square minus b square. And numerator will be 1 plus tan theta by 2 the whole square plus 1 minus tan theta by 2 the whole square. Just normal LCM. Now I will do a plus b whole square. What is that? A square plus 2ab plus b square. What about this term? A minus b the whole square, which will be a square minus 2ab plus b square. The whole divided by 1 minus tan square theta by 2. Now 2 tan theta by 2, 2 tan theta by 2 gets cancelled. 1 plus 1 will be 2. Tan square plus tan square will be 2 tan square. So I am able to take 2 outside. So this will be 1 plus tan square theta by 2 by 1 minus tan square theta by 2. Okay. Now let's go back to the class 11th formula. What is cos 2a? 1 minus tan square a by 1 plus tan square a. Correct? This is the formula. But this is ulta. Okay. So you will have 1 by cos 2a will be what? 1 plus tan square a by 1 minus tan square a. If it is a, it becomes 2a. So if it is theta by 2, 2 times theta by 2 will be 2 theta by 2 will be theta. Isn't it? 2a becomes a. So theta by 2 should become theta. Okay, or if you want, I can write it for you. 1 by cos a is 1 plus tan square a by 2 by 1 minus tan square a. I am applying this formula. Now what is cos theta? It's a by b. So it's a divided by b. Take LCM. I mean, you take reciprocal, you get 2b by a. That's exactly what you want to do. Simple question, but it's more of trigonometry than inverse trigonometry. That inverse trigonometry gets over in the first step. After that, it is basically trigonometry problem. Okay, so I don't see any reason why they should not ask this in the exam. Okay, it's very much part of the syllabus. Now, I want to know which is greater, tan inverse of 1 or tan 1. Okay. Now, you all know tan pi by 4 is 1. Okay. And you also know 1 is greater than pi by 4. Why? Pi by 4 is 3.14 divided by 4 will be definitely less than 1. So 1 is greater than pi by 4. Now take tan on both sides. Tan 1 is greater than tan pi by 4. So that is tan 1 is greater than tan pi by 4 is 1. But you know tan 1 is greater than, but 1 is greater than pi by 4. Correct? 1 is greater than pi by 4. So what is pi by 4? It's tan inverse of 1. So I'll repeat again. 1 is greater than pi by 4. Why? Pi by 4 is 3.14 by 4, which is definitely less than 1. If 1 is greater than pi by 4, taking tan on both sides, tan 1 is greater than tan pi by 4. Tan pi by 4 is 1. Okay. So tan 1 is greater than 1. Since 1 is greater than pi by 4, tan 1 will be greater than pi by 4. But what is pi by 4? You have tan pi by 4 is 1. So what is tan inverse of 1? That is pi by 4. So this part is replaced. This pi by 4 is replaced by tan inverse 1. So from this you understand that tan 1 is bigger than tan inverse of 1. So it's a very simple 1 mark or a 2 mark question. Not at all complicated. I hope it's clear. Let's go to the next question. I want to find the value of x. Tan inverse of x minus cot inverse of x is equal to tan inverse of 1 by root 3. Once again, it's not complicated. Some people will say finding x type of questions is not there. Okay, it is very much possible for us to do with whatever portion CBSE has given us. What is cot inverse of x? It is pi by 2 minus tan inverse of x. What formula did I use here? I used tan inverse of x plus cot inverse of x is pi by 2. So what is cot inverse of x? It's pi by 2 minus tan inverse of x. Very simple. Now open the bracket. When you open the bracket, minus into minus becomes plus. We get 2 tan inverse of x minus pi by 2 equal to, tan inverse of 1 by root 3 is pi by 6. Is pi by 6 because tan pi by 6 is 1 by root 3. So tan inverse of 1 by root 3 will be pi by 6. So what is 2 tan inverse of x? 2 tan inverse of x will be pi by 2 plus pi by 6. Now take LCM. LCM is 6. So I get 3 pi plus pi, which is 4 pi by 6, which is 2 pi by 3. So you have got 2 tan inverse of x equal to 2 pi by 3. 2 gets cancelled. So what is x is equal to? Tan pi by 3. What is tan pi by 3? Root 3. Isn't it simple? First step only inverse trigonometry. Pi by 2 minus tan inverse. We open the bracket, tan inverse of x and tan inverse of gets added. And tan inverse of 1 by root 3 is pi by 6. Now take it to the other side, it becomes 4 pi by 6, which is 2 pi by 3. So 2 gets cancelled, you get tan inverse of x is pi by 3. Taking tan on both sides, you get x is equal to tan pi by 3. Tan pi by 3 is root 3. So the answer is root 3. Okay, the next very simple question. Evaluate cos of 2 cos inverse x plus sin inverse x when x is 1 by 5. So what I will do, I will take this as cos of cos inverse x plus cos inverse x plus sin inverse x. What did I do? I wrote 2 cos inverse x as cos inverse x plus cos inverse x. Nothing great. Okay. Now this is cos of plus, what is cos inverse x plus sin inverse x? It is pi by 2. Isn't it? Very, very simple. Now what is cos 90 plus theta? Cos 90 plus theta is in which quadrant? Cos 90 plus theta is in the second quadrant. In the second quadrant, cos is negative. Cos will become sin. So this will become cos of, this will become sin of cos inverse 1 by x with a minus sign. Why? Cos 90 plus theta is minus sin theta. Cos 90 plus theta is minus sin theta. Now, wherever x is there, I will put 1 by 5. Now I need to find this value. So 1 by 5, I will take it as cos A. Now draw a beautiful triangle, right angle. Cos A is adjacent by hypotenuse. By Pythagoras theorem, what do you get here? Root of 9, root 24. Correct? 25 minus 1. So what is sin A? Sin A is root 24 divided by 5. So from this you can see clearly cos inverse of 1 by 5, which is A, which is same as what? Sin inverse of root 24 by 5. You see? Cos inverse of 1 by 5. Here A will be what? Sin inverse of root 24 by 5. So all that I need to do is replace this cos inverse of 1 by 5 by sin inverse of root 24 by 5. What is sin of sin inverse? It's nothing but x. So this is the answer. Very, very simple question. The first step is important. Writing this as cos inverse plus cos inverse. And this is pi by 2. Cos 90 plus theta is minus sin theta. Now I put x as 1 by 5. Now I want to convert this to sin inverse. How do I do it? I use the triangle, which you already know. And automatically you get the answer. Okay. Let's go to the next question. This is a very, very lengthy and very important type of question. So let's try to do this problem. Now what is given to me? It's given cos inverse of x by a plus cos inverse of y by b equal to alpha. This is given to me. Now what I will do, as usual, I will take x by a as cos a and I will take y by b as cos b. Because everything is in terms of cos. So what will happen to 1? This will become a plus b equal to alpha. A plus b equal to alpha. Now I'll draw the triangle. What is cos a? Cos a is x by a. This will become root of a square minus x square. What is cos b? Cos b is y by b. So this will become root of b square minus y square. So if the square roots are on same side, that is the opposite side, okay, I have to get in terms of cos. See what I do. I take cos of a plus b on both sides. I take cos on both sides. You may ask a question, why can't I take sine on both sides? Just a minute, we'll find out why I'm taking cos on both sides. So this will become cos a cos b minus sine a sine b. By taking cos, see what has happened. My cos a is x by a and my cos b is y by b and my sine a is root of a square minus x square by a and this is root of b square minus y square by b. The advantage is I have got all the square root together. If I take cos, I'll get them together. If I had taken sine, I would have got sine a cos b plus cos a sine b, where there will be a square root on both the terms. Nothing wrong. The steps will increase. In this way, I am able to isolate the roots, square roots separately. So I always tell the people that if you have square roots on the same side, you take cos. If the square root is here, you take sine. Okay. In that way, your root will be together. It's easy to handle it. So now x by a into y by b minus cos alpha. I'm bringing this term this side and I'm taking this entire term to the other side. It's root of a square minus x square into root of b square minus y square by ab. By ab. Now what do you do? Squaring both sides. What is a minus b whole square? A square. This I am still in a square. Okay. A square minus 2 a minus 2 a is still there. This is a. 2 a b. B is cos alpha plus b square equal to, I'm going to square this. When you square this, the square root will go. When I square this, the square root will go. This will become a square b square minus a square y square minus b square x square plus x square y square divided by a square b square. You see this? I'm squaring both. I get a square b square. Root will go, then I open the bracket. A square b square, a square y square, b square x square plus x square y square. Very simple. So now this will be x square by a square into y square by b square minus 2x by a into y by b cos alpha plus cos square alpha equal to, I am splitting this now. A square b square by a square b square is 1 minus a square y square by a square b square. Here a square and a square gets cancelled. I will get y square by b square. Again, if I split this, b square and b square cancel, you get minus x square by a square. And here it will be plus x square y square by a square b square. You understand what I'm saying? I'm just splitting each term. Okay? Basically dividing. Now you see these two gets cancelled. Correct? Now I will take this term to the other side. What will happen? It will become x square by a square. Then I will write this. Minus 2x by a, y by b, cos alpha. And I take this that side. I will take this that side. Plus y square by b square equal to 1. This 1 is there. Now I take cos square this side. What do you get? Minus cos square alpha. Now what is 1 minus cos square alpha? Sin square alpha. Is this what I wanted to prove? Isn't it a lovely question? It is lengthy but not difficult. Plus y square by b square. All that you should know is take x by a as cos a and y by b as cos b, you get a plus b. Then you should know whether I should take sine, cos or tan. For that I gave you reason. You take cos on both sides so that the roots are together. After that there is no trigonometry, nothing. It is just algebra. Squaring both sides. The moment you square both sides, you get the term like this. Split it and then regroup it, you get the answer. Very, very easy. Now this is an NCERT question which I like, very important sum. So let's try to do this problem. See, both the questions look same, but the domain of definition is different. Okay. But easiest way to understand is, this is what I wanted to prove. So here I'll take x as sine theta. It will become sine inverse of 2 sine theta into root of 1 minus sine square theta. So what is this? Sine inverse of 2 sine theta, and this is cos theta. What is 2 sine theta cos theta? It is sine 2 theta. What is sine 2 theta? 2 theta. What is sine inverse sine 2 theta? It's 2 theta. What is theta? Sine inverse of x. Simple, isn't it? Now, if you want to understand all this, it's given minus 1 by root 2 less than or equal to x less than or equal to 1 by root 2. But what is x? X is taken as sine theta. So sine theta is 1 by root 2 minus 1 by root 2. So taking sine inverse on both sides, theta is less than or equal to pi by 4 less than or equal to minus pi by 4. Since I want 2 theta, multiply throughout by 2 less than or equal to pi by 2 less than or equal to minus pi by 2. So clearly you can see it lies in the principal range. Therefore sine inverse of sine 2 theta can be written as 2 theta. If you had put cos theta, you will have a problem, okay, because it will not lie in the principal range of cos. Okay. Now let's try this. This problem you can try by yourself. This problem you can do by yourself. Here if you notice, here it is 2 cos inverse of x. So you put here x is equal to cos theta, don't put x as sin theta. Okay, I think you can try that and get it. Both these two sums are NCERT questions that are little different because of the domain of definition. I hope this is very clear to you, and we'll continue with functions and relations in the next, we'll go to the next chapter called functions and relations. I will start putting the video on that. Hope these videos are very useful to you. Okay, please subscribe to the channel and also click the bell icon. Have a nice day. See you. Bye bye.